Hello and welcome back to Mr. Powers Teaches Algebra. We have been, in these first two videos, we're talking about graphing polynomials. We've been talking about what polynomial graphs generally look like, so their attributes and their behaviors. They're continuous, they're smooth, no jaggedy edges, no asymptotes. And we talked about the roots, what happens in the roots with different multiplicities. And we talked about end behavior. So now that we have all of that stuff in there, let's use it all and graph an example. Okay? So here's our process for graphing a polynomial. And these are the steps. You don't have to follow these steps precisely in this order, but it is good to include all of these at least. Okay? So determine all the zeros for a polynomial and their multiplicity. Determine y-intercepts. Okay, so we get our x-intercepts, get our y-intercepts. Nothing new there. Use a leading coefficient test to determine behavior of the polynomial at the ends. What's it doing on the left side of the graph? What's it doing on the right side of the graph? And plot a few more points so we can get a little bit better idea what this graph looks like. And when we say sketch, you know, it doesn't have to be perfect, but we want the big things right. And the big things are what we've been talking about. Okay. So, oh yeah, and a quick warning. So a note. This process assumes that all zeros are real numbers. Okay? Remember, we've seen it before that we can have zeros pop up that are complex. And in that case, let's see, if there are any complex zeros, then this process may miss some pretty important features of the graph. Yeah, it'll be a little different. Okay, so let's do this one right here that we got. Okay, I think I might move this over a little bit, give ourselves a little bit extra room over here. And let's start messing around with p of x equals x to the fourth minus x cubed minus 6x squared. And I do like to find my roots first. And I think I forgot to calibrate my graphics tablet. Hold on a second. All right. No, it looks like it's okay. So let's go for it. There we go. We be drawing. My head's not in the way. I think we're okay. All right. So first off, what I need to do, find my roots. Where does x equal 0? Ooh. There we go. I'm sorry, p of x equals, yeah, where's p of x equals 0? So I want to make, p of x equals 0. So we need to make p of x equal to 0 and solve. So we need to solve x to the fourth minus x cubed minus 6x squared equals 0. All right, piece of cake. Well, whenever we're solving quadratics, and now these are like quadratics but harder, we'd like to factor if we can. And so we are still doing that. I notice here a common factor in each term is x squared. So what I end up with, I could take that x squared out, and I get x squared times x squared minus x minus 6 equals 0. That's awesome. Okay, so that's a factor. That's easy, and if it really helps you, you can imagine x squared as the same thing as x minus 0 squared, if it helps. You don't really. But we know we have a root at 0, multiplicity 2 with that one. But this one, we got to keep going. So let's go ahead and say, well, what do we got now? We got x squared times x minus 2 times x minus 3 equals 0, but one of those needs to be a plus. One of these needs to be a plus. It's got to be this one. And there we go. That should do it. 2x plus negative 3x is negative x. 2 times negative 3 is negative 6. X times x is x squared. Got it factored. All right. Now I know where my zeros are. Got to stop yelling. Okay, so here we got a 0 at x equals 0 with multiplicity 2, because we've got it squared there. And then these all have just roots with multiplicity 1. We got one at x equals -2, and one here at x equals 3. So step 1's out of the way. Let's go ahead and get our y-intercept, and that's really easy. That's just finding where x equals 0. So what is p of 0? Whoop. So p of 0. What's p of 0? That's going to be 0 to the 4th minus 0 cubed minus 6 times 0 squared. Oh, you got to love it. That's 0. So we got more points. That gives us a point at 0, 0. That's awesome. So we already got all these points. I'm going to start plotting them here. I know we got a point here at 0, 0, and that's my y-intercept. But it's also an x-intercept. I had it right here for a root. And I know right around there, it should be going up like this. So I'm going to go ahead and kind of get that little curve in there to show them, just to remind myself, okay, when I'm going through there, it's going up because I got an x squared. And it was positive x squared too at the start. So I know my end behavior. I guess since I'm talking about that, what's our end behavior? We have x to the 4th as my leading coefficient. Y equals x to the 4th. If I was going to graph that, would it be like a really kind of like a wide U, like a parabola, but a little wider at the bottom. So I know on my left side, as I go left, is going to increase. As I go right, it's going to increase. I know that. Okay. So let's see what else we got. Let's get to its other roots. So I got distracted. -2. We got one at x equals -2. And we got one at x equals 3. So that's going to be right about here. Okay. Great. So let me see here. I know it's an x to the 4th. Oh, so you know what? This one, my blue one, is wrong. It is going to touch, but it's going to be touching upside down here, like this. And how do I know that? Because my end behavior, I know up here somewhere I'm going to be going down because it goes up on the left side and up on the right side because my leading coefficient over here. Oops. Which buttons am I trying to press? There it is. Jeez. Okay. All right. Yeah, because of this guy, I already know that I should be increasing on the left and the right. So this is my leftmost intercept, my leftmost root. So I know on the left side of that, it's going to be positive. This is my rightmost intercept. I know on the right of that, I'm going to be positive. That's what I know because it's endpoint behavior. So without testing points, right now, I know the shape is going to look like this. And then touch right there, go back down, and then go back up and up like this. I know that already. I have that down. But what's the last step? What is our last step? Because I think I did the first three. I used the leading coefficient to determine the end behavior. I found my y-intercept, I found my x-intercepts, and I counted the multiplicities there. Now we should find a few more points. So we should find some points in between these, just to be sure. So if we want to be really, really thorough, right, and we want to be like, as a quick sketch, for me, I'd be fine with this. This is a quick sketch. But if I want to be extra sure, extra certain I didn't make mistakes, and I want to be a little bit better with my sketch, then I'm going to find some more points. I'm going to probably find f of, let's say, -3. I'm going to find f of -1. I should say p, sorry. I forgot our function's p. Okay. I should find p of, let's say, this is 3. I don't know, p of 2? Actually, I like p of 1. 1's easier. And then one more out here. How about 4? P of 4. We should find all of those values. I'll go ahead and do one of those with you really quick. And then the rest I'm just going to put up because it's easy stuff. We should know how to do this already. Actually, hold on one second. Watch this. Okay, and there it is. So I showed the steps for the first one. P of negative 3 would be negative 3 to the 4th minus negative 3 cubed minus 6 times negative 3 squared, because that's our function. And we would have gotten 54. Now, 54 does not even fit on the grid that I have copied that I'm using, right? But we can tell if we were to follow that, man, it would be super steep. It would be going, on this side here, it'd be going like just, like we got to hit 54 by 3. Like that's even not enough. Let's see here if I can do this. This is tough. It would be really, really, really steep. Really steep. Okay. Oh, geez. It wanted to make it straight. Whatever. It's going to be super steep. Okay. It gets big really quick. P of negative 1 is negative 4. So we'd have right here. So it's pretty steep still, right? So it's going to curve out a little bit. And then at some point come back this way. Touch there. At P of 1 is negative 6. So 1 is negative 6 there. So it's going to touch and go way down here. Oh, and it shouldn't go backwards. So let me see. I'm not the best. Like, it's hard enough drawing on a graphics tablet for me. And then back up. Oh, one more time. I'm sorry. There, you know, it's good enough. And then even then it's going to be really, really steep again. I'm just going to draw an arrow here because I give up. P of 4 is going to be negative 6. It's going to go, again, really steep. So that graph, it's kind of what it looks like. So I got a little bit better shape there. Not as pretty graph, but there it is. Now, if we want to check it with technology, super easy as always. Go to GeoGebra. That's GeoGebra.org/calculator. Make sure you're in the graphing mode. Graphing right here. And literally type in P of X. Exactly what I have here. Equals X to the 4th. There's a keyboard if you need it. There it is. Get out. Okay. Minus x cubed minus 6x squared. And it'll graph it for us. And we can definitely see these values. And actually, if I wanted to, instead of going P of negative 1, I could have gone, make a point, negative 1, comma, P of negative 1. And it would show me that. So actually, that wasn't even the lowest part, negative 4. I drew it as the lowest part because I only tested 1 point. But it actually went down really quick and then went back up. So we can see where those points are. And a really neat thing too here is you can always go table of values. And let's say I want to go negative 2 to, let's go negative 3 to 4, going by ones. And we got these points. So negative 3 was at 54. Negative 2 was 0. We had our zeros. 1, negative 4. We got all these fun points now. There we go. I'll show you all those. So that's really nice. And it gives us a good idea. So we did a good job on that. That was a good sketch. We did fine. And if we want to get other points, hit 5. Oh, man, this thing grows really, really fast. Maybe I didn't want to go to 2. Maybe we could have done, oh no. Anyway, it doesn't matter. Okay, so I just want to show you that. I think we're good. Yeah, we are good. That was an example. So I hope you found that useful. And until next time, enjoy doing math.